Hey everyone, Michael Unger here with another edition of Ask an Astronomer, the last Ask an Astronomer of 2022. And as we have all year, we have our trusted astronomer, that is Marley, a few doors down from me. How's it going, Marley?
It's good. It's good. Sunny day, albeit it was still a bit chilly, but at least there's some sun.
Yeah, a little bit of a chilly, sunny day here on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh. Shout out to my sister down in Australia, where because of this weird tilt that we have, it's summertime down there. Maybe my nieces are up watching as well. But it's my sister's birthday tomorrow, so shout out to Chelsea. I don't know how we don't talk about ages, but another lap around the sun.
Happy birthday, Chelsea.
Well, Marley, this is our year in review show. And 2022, what a year it's been. For us here at the Space Center, we opened up, we had all of the public come back, all of our public programs. We did our first 19 plus Cosmic Night a few weekends ago. We've had lots of programs, so much to talk about. But let's do a year in review. We kind of like look back at all of the stories that we've done here at Ask an Astronomer, which connects to all of the news that's been happening. There were certainly some themes that came up, a lot of topics that we talked a lot about this past year, but still some things we can kind of like look back on and gain some perspective on these particular topics. So let's do our 2022 year in review. If you are watching on YouTube, throw a comment or a question into the chat as well as for Facebook, and we'll answer all of your questions, whether it's the topics that we cover here in our review of 2022, or if you have any other random question under the universe, we'll answer those too, or at least we'll try to, right, Marley?
Yeah, I'll try. That's all I can do.
Let's get to it. Of course, our 2022 year in review very appropriately ended one of the most anticipated missions in a long time just a few days ago, and that was Artemis.
Yeah, the Orion splashdown. So this happened on December 11th at 9:40 in the morning, almost on the dot. Their timing was quite good for the splashdown. And it actually occurred 50 years to the day of the final Apollo moon landing of Apollo 17, which I thought was a happy coincidence. So despite every setback that this mission had, it was a nice bow on the entirety of moon exploration, it felt like. While it was in space, the Orion capsule performed two lunar flybys, coming within 130 kilometers of the lunar surface, which is quite close. And upon its reentry to the Earth's atmosphere, it slowed down. It was going 40,000 kilometers per hour, and it slowed down to 30 kilometers per hour prior to unleashing its parachute. So a very dramatic slowdown when it came back. But it was a very successful reentry and splashdown. I watched it quite nervously. I always get nervous when things re-enter because I'm like, it's just going to explode. But it didn't. And it made it down quite well. But it was a nice story to end off with. And it really did show off, kind of our big themes. Why does my PowerPoint hate me? Okay, that should say missions. And what did we talk about? We talked about the James Webb Space Telescope was a big one. Everything is wrong. Talked about Webb, Artemis 1. Wow, this is okay. So Webb, we had the first images this year and all the science since then. For the Artemis 1 mission, we had, of course, the Space Launch System, the unveiling and the launching of that finally, Orion and all of those CubeSats. Mars, I don't even know where the Mars title has gone. That was Perseverance and Insight, big ones, as well as Ingenuity. And then we had a lot of kind of other stuff sprinkled in throughout the year. And that was kind of black holes, asteroids, the decadal survey, a bunch of space junk talk. And that was kind of our whole deal with this past year. This is an ugly slide, so I'm going to skip it. Okay.
Yeah, certainly Artemis was certainly a big focus because this is our return to the moon, and this is actually where the Canadian Space Agency has been getting involved. They are part of the Artemis mission. Artemis 2 is going to have that first Canadian. So there was certainly a lot of interest as Canadians with this mission, and it got delayed a lot. So that just like kept on ramping up the anticipation of when this thing was going to launch. And there was a lot riding on it too, right? Like this is a huge deal for NASA and for the future of human space exploration.
Yeah, it's not just for exploring the moon, right? Like the Artemis missions are focused on lunar exploration for sure, but everything we learn from them goes on to tell us about what we can expect and what we need to learn for and prepare for exploration of Mars. So a lot is riding on this. Like this SLS is the rocket that will take us to the moon and beyond, right? It will continue to learn from this first configuration of how we've had it and how to adjust it and readjust it for us getting to Mars. And same with the Orion capsule, right? Like learning about what radiation astronauts can expect to experience, what levels of radiation, the impacts of weightlessness, all of those things, right? In that um, space between planets, not just the space between the Earth and the moon, but the space between the Earth and Mars, right? We have to learn all about that and prepare for that as well. So a lot was hinging on this mission going well in particular. And once it finally got there, I don't want to go through all the thousands of things that ended up delaying it. But once we got there, it really did pay off. And I expect we'll learn a lot. And about the astronauts, because this is something I've been very interested in. Who is going to be the Canadian astronaut? Who are going to be the American astronauts? When are they going to announce that class? When I was watching the coverage for the splashdown, they had a former astronaut on board. And what she was saying was that when they announce the class will hinge on when they plan to launch Artemis 2, because they have to go through such a set of training, right? I think it's like 16 months or more of training. Yeah. And so they won't announce the class until they know when they're going to launch the mission. And so that's been speculated to be in May 2024. I really think it's going to get pushed back to 2025 just based on everything that's happened with Artemis 1. And so 2025, or even maybe I would say, 2025 is what I think anyways. And so we might not know the class. At one point we were told, or they hinted out we would know the class by the end of this year, before the end of this year. I don't think we're going to know the class until sometime in 2023.
Wow.
Yeah.
So that's really like the the weight of all time, really, for these astronauts. Some, in the case of like say Jeremy Hansen, he's been waiting a very long time. One of the 4 Canadian astronauts. We've got Jeremy Hansen. We have David St. Jacques, who's already been on the International Space Station
a couple times.
Joshua Kutrick, who was here just a few months ago, and Jenny Seide, who had visited us a few years ago as well. So we've got 4 potential Canadian astronauts. One of them is going to be in Artemis 2. So very exciting.
Yeah. I do think it'd be very funny if Chris Hadfield ended up on it, though. That would be hilarious. Yeah, he won't. He's in retirement, but that would be very funny. Maybe an idea, but
we also have a mock dummy of Bob Thirsk that maybe they'll just send the mannequin of Bob.
Send the mannequin of Bob. Oh, speaking of the mannequins, they've recovered them out of Orion. And they will be tested. I don't know. I really don't like to read much about them because they kind of freak me out. But they will be tested about radiation, and they had all these sensors on. So all of that science will not come out by the end of the year, but will start to come out in 2023. What happened to everything on board Orion?
Yeah, those poor little guys just floating there in that capsule.
They had no heads, or it was just
But that re-entry, as I've heard lots of people talking about this mission, that re-entry is one of the most crucial things that they were testing, because you've got to get it right. And that heat shield, that's one of the most crucial things to the safety of those astronauts coming back home.
Oh, yeah, it is. It is, kind of the whole mission. If it doesn't make it back to the ground, there goes a lot of the information that you got, right? So it needs to get back to Earth. And it's very crucial, especially if it's for, if there's people on board. But the way that Orion re-entered, it was called a skip entry maneuver is how it re-entered. And it was the first time that maneuver was attempted for a human spacecraft. So a spacecraft that's meant to hold people in it. And so it's kind of like skipping a stone across a pond. But not quite, right? It's more like it dipped into Earth's atmosphere, came out, and then went back in for the final reentry. And what that does is it dramatically slows it down and kind of reduces a lot of the force, like spreads it out over more time, sort of thing. And so it was the first time they did it. And so that's why I was like, it's just going to blow up. Like, there's no way. But then it worked really well because they've done it before, of course. It was just the first time with a human spacecraft. Or a spacecraft meant to have people on board. And it worked. It seemed like, it landed. Everything worked the way it needed to. And so it was a good move. And hopefully it'll happen again. It'll be fine.
Well, there you go. That is Artemis 1. So if you have any questions about that first rocket that did some loops around the moon and then came back on a skip reentry, as Marley just said, throw them into the chat. And as if that wasn't, big news enough for this year, we may have had an even bigger news story, possibly the biggest, the most expensive, certainly, space telescope that humans have ever built. Finally got up there, finally started to release some images, and that is the JWST.
Yes, I think this telescope is just constantly looming in the back of my brain at any given moment. I'm like, what is going on? What is it up to? But yeah, back in March, we ended up getting we got these alignment selfies, right? So this was all the way back in March after it launched in December, and it set out its sun shield and it cooled down. I go through these steps. We got the alignment evaluation image. That is a star, right, with its diffraction points, and then the near cam alignment selfies showing all the segments of the mirrors receiving light and all lit up. And this was all the way back in March. And so the Webb spacecraft, the Webb telescope, really was almost an exercise in extreme patience, because I just wanted the pictures and I wanted them right away. And that's not what happened. We had to go through all these steps, right? Which, of course, makes sense. But I distinctly remember when this image dropped down, the telescope image sharpness check. And that's kind of when I was the first like, oh boy, like this is actually going to be a lot cooler than I kind of expected it. Like you can't really imagine what the telescope will show you until I saw this image. This came out on April 28th. And it's showing, the image sharpness, the detail you're getting out of all these. And these are just engineering images, right? They're not scientific images. They're just testing to make sure that the instruments were working. And they're so sharp and there's so much detail. And then we had to wait all the way until July 12th. And I remember trying to figure out when they were going to release the images, because they're being very quiet about it. And there was a conference happening. I can't remember where now. I think it was in Finland, maybe. And I saw that on the schedule for the conference, it was talking about Webb's first images. And the conference ran from the 10th until the 15th of July. And I was like, I have dates. It'll have to be sometime here, finally. And it dropped on July 12th. That is when we got the images. I was on vacation, but I remember we hosted something at the Space Center here. I was back in Calgary. I actually watched the images come down with my grandparents who watched the show and my mom. It was very cool. And we, of course, get Webb's first images, right? The Carina Nebula, which was, is just such a phenomenal image. If you haven't been here yet, come and we have this image put up on the dome, and it's like very kind of all encompassing, but very cool. And Stephan's Quintet, the Southern Ring Nebula, which is a great image. The hot gas giant exoplanet atmosphere composition. This was very much a Canadian endeavor. I think you had guests from the Canadian Space Agency come and speak about it, because they got dropped during the telecast, which was extremely disappointing, because this is very cool. But there's an episode I think we have all dedicated to the work done. And then, of course, the Galaxy Cluster Webb's first deep field image, which was very exciting. And I remember my grandparents being like, what are we looking at? And I was like, give me 10 minutes and I will calm down enough to be able to tell you what we're looking at.
Oh yeah, certainly that's my favorite image of all those that deep field image. It's so subtle and so serene, and then there's just so much going on. Like the more you look at it, you get it on a big screen and just stare at it for hours. It's just beautiful.
On the Webb Images website, they have one that's quite large that you can like zoom into different sections, and it's quite fun to just like zoom into a piece of the image and just like look at it and look at all these different galaxies. And I think like the oldest galaxy ever is in this image somewhere that we found so far, or it's a candidate to be that, is in this image. And it's just like, do another deep field, like let's go. This is so cool.
Yeah, just zoom in there and see if you can find Waldo in there somewhere. The Waldo Galaxy.
Waldo Galaxy. Yeah. Oh man. And then of course Webb ended up looking at our own solar system as well, right? So we got this gorgeous image of Jupiter in the infrared, and then of course this picture down on the side of Neptune close up with its rings and moons. And it's such a great telescope. It's really good at what it does.
Yeah, it's such a stark contrast. It's interesting when I hear a lot of the engineers talking about this, and they compare what happened with Hubble. And this was really kind of like very different, because when Hubble was launched, it didn't work. But there's a lot of similarities. I saw like a video of the same kind of thing that we did, where we were live all across, the world, watching these images. They had like videos of all of like the scientists, but it was interesting because you could just like see on their faces as they saw those first images come back that they were like, oh no, this isn't working.
It was blurry. Like it worked.
Yeah.
It worked with what it was given. Like Hubble, it did its job. It was looking. It's just the mirror was wrong.
Yeah.
But yeah, I can't imagine the devastation of seeing the images come down and be like, oh no. But at least
Yeah.
Hubble was close enough to fix.
Yeah.
Webb not doing that, really one shot to get it right. And they got it extraordinarily right. The fact that this telescope is working at and it's sometimes beyond what they expected the operational capacity to be is very exciting. And I think its planned mission is only 5 years, but they anticipate to get over 10 out of it. So I really hope we get that over 10 because I really am excited to see what it can do.
Yeah, absolutely. And those stakes couldn't have been higher as well, because this, again, was what was definitely the most expensive
Yes.
piece of equipment that humans have ever sent up. And again, not just NASA, Canadian Space Agency, again, has gotten
European
involved.
Space Agency.
European Space Agency. These are now worldwide endeavors. And I love the collaboration because that's how science works now. It's all these scientists from all different disciplines all working together. Such fascinating stuff. So those are two the biggest missions that we could possibly talk about. And if we couldn't get any bigger or more exciting, let's go back to the world that we hope to send humans to next. We're talking about sending humans to the moon, but Mars, where we've got a couple rovers that have been doing some great work this past year.
Yeah, so Mars always in the news, right? With Perseverance, being there, and Ingenuity, the UAE orbiter, InSight, the Tianwen-1 mission through the Chinese Space Agency. There's a lot going on this planet, but we mainly talked about Perseverance, Ingenuity, and InSight towards the end of the year. So to kind of break them down, InSight is the lander, right? It doesn't move; it landed in one spot. And the news about InSight was actually quite sad, and it's the fact that by the end of the year, we don't expect to hear back from it anymore. It should be mission end and it will die. It's gathered information about Mars's interior layers, the liquid core of the planet, weather, not earthquake, but quake activities, I guess, all happening in the planet, right? Which helps us understand Mars's geology a bit more and also helps us, understand these mechanisms that can cause these events that we even see on Earth. In its time on the planet, it detected over 1,300 Marsquakes. There's 1,300 Marsquakes since it touched down, and it touched down in November of 2018. And it really it re-entered the news because in the summer, the team turned off all other science instruments because, as you can see, the solar panels of InSight are covered in dust, Martian dust, right? And so it has no way to recharge its batteries, no way to power a lot of those systems. And the one system they wanted to keep was the seismometer, right? The one that detects the quakes. So they turned off everything else. They even turned off the fail-safe that's included. So typically, if they're running an experiment or running an instrument, there's a fail-safe that'll auto turn off the experiment if the battery gets too low. They turned that fail-safe off. So basically, it will run the seismometer until it died, right? That's what their thinking was. It can no longer afford to run the seismometer around the clock anymore. So they actually turn it off, turn it on when they want to use it. And recently a regional dust storm came through and they had to turn off the seismometer. If they'd left it on, it probably would have died very quickly. Once the storm ended, they turned it back on. So InSight's not gone yet. It's still doing what it can, but it will be gone soon. I think right now it's working on 285 watt hours, right? So not a lot of energy going through it at all. And it's sad, but what made me kind of teary-eyed was the fact that the team on Earth packed up Foresight, which is the full-size engineering model that they use on Earth, right? So most spacecraft have one. The engineers use it to practice how InSight would have placed its science instruments on the ground, or if something happened, they mimic the problem on Earth and then they try to fix it, right? And so they packed that up, which is like really kind of like, oh, that's the end. Like we're done. So goodbye to InSight. It could last out till 2023, but definitely early 2023, it'll be gone.
I had no idea until you just said that the Earth model is called Foresight. That's the first time that I've been hearing this. This is amazing.
Well, they love their names. I don't know. It's good.
And really with InSight too, it wasn't there was a lot of things that didn't go right with it. There's a lot that, they were able to, a lot of science they were able to get out. But I think one of the things that it learned by not being able to do was get down deep enough in the soil so that seismometer could really, understand those Mars quakes at a deeper depth. But there was something, about that Martian soil that made it either the instrument just couldn't dig, in more efficiently, or there's something about the Martian soil that we didn't know, right?
Yeah, I mean the Martian soil, right, it's not the same as Earth soil. Like that regolith, it's different. It's got all, like if you see it in the Perseverance images, right? It's a completely different landscape going on. And so I can't remember the specifics of it, but I know it did struggle at first getting the seismometer in and everything, falling around it, and just lots of different dust and debris coming in around. And they also got a lot of noise, right, from the seismometer. And so part of it was trying to figure out and develop ways to reduce the noise that the seismometer was detecting so they could get a clearer picture of what was actually going on inside of Mars.
Yeah, and then that, just kind of shows, all of these things, this mission especially, what could have been fixed with a actual astronaut there, right? Even just like getting a seismometer, into the ground, and the dust covering the solar panels. It's hard to have these robotic missions and have them all remote so far away. It just amazes me that they even work at all by building something, sending it to another planet, having it land, and then having all these very precise instruments that are all being worked remotely. Just wild stuff.
No, it's very complicated. I don't know. It's great. It's a good space. I'm sad it's going. It did a very good job, at the end of the day. It did and so did the team. So good work, Insight team.
So we've only got 8 minutes left. So let's zoom through some of these stories. A couple more missions on Mars, and then a couple really fun missions. And my favorite is I want to get to as well before we end.
Okay, we'll make sure we get your favorite. So Perseverance, of course, big one. It's collecting lots of samples. 18 out of the 43 sample tubes it has have been closed entirely. We have all but one here because one of the samples was an atmospheric sample. So there's not really a great picture of that, but these are all of the rock samples that they've taken so far. The last one was collected and sealed December 7th, so quite recently. Perseverance, of course, still trucking around on the Jezero crater and the Delta now, taking all the information it can. They did develop or kind of settle on how they're going to do the sample return mission, which I talked about a little while ago. More updates on that for getting these samples back to Earth. Of course, Ingenuity. I just love him. I just love this little helicopter. He's just so fun. The first flight, April 19th, 2021, and we're still flying. And it was only planned to have, I think, 8 flights. So I think it just did number 36 or was about to. Like, it's great for, for what it is and for what it was meant to do. It's far surpassed expectations. We almost lost it. Remember, it lost contact in May. That was very stressful. And of course, it's solar powered, right? So we have to worry about the dust, same as Insight. And it's not built to withstand the cold very well, right? Its batteries are not meant to do that. And so getting through the Martian winter was difficult for Ingenuity, but it kind of looks like it might come out of it with, the ability to do a bit more flights and a bit more movement. So I hope to see more of this little spacecraft. I love him. He's so fun.
And really game-changing too, for not just going to Mars, but for other places too, to be able to create basically a drone that can scan around. Like you have having a rover and drone working together. This could be something that could really revolutionize the way that we explore worlds like Mars.
No, it was so smart. I don't know. Like I was like, why did we never do that before? And I guess because we didn't know how, right? There has to be a first for everything. But the fact that Ingenuity is able to scout ahead, find interesting sites, and then Perseverance can just drive over, it saves time on Perseverance as opposed to just wandering throughout. It gives the science team more data to look at before choosing a target. Like it just makes so much sense to have a little scout to go ahead and look for you. And it helps, for future missions as well, learning about how to fly something on a completely different world, right? Can be used with Europa Clipper, for example, and all those upcoming kind of helicopter-y missions.
Yes. All right. Let's get to my favorite mission of the year. And I don't know why it was my favorite mission. I think it was something about the immediacy of when the impact happened and the drama of this world just getting closer and closer and closer until it was so close and then just that is the DART asteroid impact mission.
Yeah, this was cool. I also watched this live. It was impact was on September 26th. And so on the left, we have the moonlit Dimorphos, which is what DART hit 11 seconds before impact. The spacecraft was 68 kilometers away. And so the spacecraft was moving quite quick, because the next image on the right is the last complete image before impact, 2 seconds before impact occurred, and it was 12 kilometers away. And the actual final image is just the top maybe eighth of the image, and the rest is just well, when it was broadcast it was red, which was quite dramatic, but then they changed it, I think, to black or blue. Yeah. But because it died while it was sending the picture. It was successful. We knew pretty quickly afterwards that it had been successful. The orbital period of the moonlit asteroid had changed, and it worked. It was great. And then every telescope it felt in the world turned to look at it, and it was fun to see.
Yeah. And I mean, there's also something about looking at this world that was just like a tiny little like pixel on screens before, because it was so far away. It's not very big, doesn't reflect a lot of light. So as it got closer, and I saw reactions of a lot of planetary geologists that were just sort of like, whoa, like getting all of this detail in real time so quickly. It was very cool to kind of like see how scientists are looking at this mission, even just like, planetary scientists, looking at these small worlds. And then, of course, thinking about planetary defense, which is a very big and important topic that is, useful for everyone on this planet. This is something that everyone on this planet should be interested in, right? But it was also cool to see a potential way that we could redirect these things coming towards us.
I think it also just fulfilled a very human desire to throw things at other things, like I think we just enjoyed doing that. And then we did it on a very big scale, and it was fun. Absolutely. So, and we got a lot of science out of it. So a win for everyone.
Yeah, just got to send Bruce Willis and Ben Affleck back up there.
Was Ben Affleck in that one?
Oh, yeah. Have you never seen Armageddon?
No, I have. I just have no idea who Ben Affleck is in that one. Who is he in that one? Oh, is he the kid?
Yeah, well, he's the one that is in love with Liv Tyler.
That's Ben Affleck?
Yeah, that's Ben Affleck.
Wow. I guess I didn't notice. I didn't see his giant Phoenix tattoo. Okay. So...
that was before the whole Phoenix era. Okay. This was the young Ben Affleck.
Okay.
In our last few minutes, let's get to some of these other stories before we end off the show.
All right. There was asteroid Ryugu, which was very, very cool, but I'm going to skip to one that was a bit cooler, which was, this. I would be like, I don't know, chastised by many of my astronomy friends if I did not mention the image of Sag A star, right, which is the black hole at the center of our galaxy, 4 million times more massive than our sun, 27,000 light years from Earth. Getting this image, like its distance, and taking a picture of it was like, I think they described it as looking at something that's the size of a donut on the moon. So like just an incredible feat of technology and this collaboration. And just so cool. I don't know. May was a great month for some of this news. This in particular, as well as the decadal. Oh, not asteroid Ryugu. Sorry, buddy. The decadal survey, right? So this came out this year. The planetary science one. There's a separate one for stellar science, where the 2 flagship missions were decided to be one to Uranus, the Uranus orbiter and probe, for origin, interior, atmosphere of Uranus study, along with magnetosphere and its satellites and rings, because we don't actually know a whole lot about the ice giants or what's going on with them. And then the second flagship mission being the Enceladus Orbilander, which was its mission kind of is to search for evidence of life and information to help us contextualize how we would detect life on a world such as this, or on a world different from Earth. So that was fun. These flagship missions were interesting. I wasn't expecting Uranus, but it makes sense. I was expecting Enceladus, but it was still cool to see. And to end it with my personal favorite story, which may be slightly underwhelming, but not to me, is when we finally got the image of the Pillars of Creation. I waited so long. I was so convinced this was going to be one of the first images the telescope put out, and I was a little mad when it wasn't. And so when it finally dropped, I was so happy. So here's a comparison between Hubble on the left and Webb on the right. And then they just spoiled me. They gave me, me personally, a near infrared image, which is on the left, and the mid infrared image on the right. And then they gave one a composite of both. And it's just, I love
Dang.
this. I love this image. It is the space image. I feel like, to me, this nebula is the thing you show someone when you talk about space. So I was so happy they finally gave it to me.
So when somebody asks you, what do you do, Marley? You're just like, this is what I do. I think
Well,
about this.
I think about this all the time, and I make a lot of silly little PowerPoints.
Well, thank you for making so many silly PowerPoints this entire year, Marley. This has been a blast to do the show with you. Can't wait to get into it next year with a whole new schedule and a brand new time. So our schedule for Ask an Astronomer in 2023, we're going to be back. We're going to take a couple of weeks off. We're going to be live on January the 12th at 4 p.m. Pacific time. So make sure that you subscribe and make sure that you've got those notifications on, or put it in your calendar. 4 p.m. Every second Thursday starting January the 12th. We will be here with lots of surprises. We're going to kick it off with a preview. So we did a review of 2022, 2023. Wow, can't believe I'm saying that out loud. 2023 is what we're going to be talking about at our next show. Marley, amazing as always. Thank you all for watching on YouTube. Have the best holiday season. We will see you all in 2023. Happy birthday, Chelsea.
Bye.